So for this section, I'm not going to give you all the answers, but I'm going to try to clarify and give you some direction on some of the questions here. For example, questions 1, 2, and 3, it says, describe the three forces encountered in everyday life. I think you can do that one. It gives you an example, braking in an automobile. You could use like force going around a turn. Any kind of force is encountered. Basically, you know what a force is, a push or something like that you can feel. We feel gravity every day pushing down on us or pulling us toward the earth. That's an example of a force. Number 2, it says use vector diagrams to represent the forces acting on an automobile traveling at a constant 60 miles per hour. This is kind of a trick question, but the idea here is that you're going to have, you know that anything that's traveling at a constant velocity is going to have equal forces acting in all directions. So if I were to draw a block, if it's moving, if it's at a constant velocity, whatever that may be, the forces would be like that. Or actually, to draw them better, I should draw them like this. So for an automobile, I want you to try to think of real forces, though, not just draw arrows, but you get the idea. There's going to be forces acting in all directions, and then they're going to be equal and opposite, because they're all going to be equal to 0, because it is it's traveling at a constant rate. It's not accelerating. Anything that's not accelerating has equal forces. So number 3, you're trying to figure out the force on your body while moving up and down in an elevator. A lot of people have this question. I'm going to give you a hint here on number 3 and say, what do you use to measure the force on your body in everyday life? The force from, let's say, gravity. What do you use to measure the force on your body from gravity? Now think about that. People use this, a lot of people use it every day to measure the force of gravity on their body. How would that work in an elevator? Number 4 says calculate the net force acting on an object that has 12 newtons acting down, 3 newtons to the right, 6 newtons up, and 8 newtons to the left. So we need to find the net force first. So I would draw a block, and then we'd have 12 newtons down, 3 to the right, 6 up, and 8 newtons to the left. So first thing we do is cancel out the ones in opposite directions, so that would leave us with 5 to the left, and looks like 6 down when we subtract the 6 and the 12. So subtract 8 and 3, we get 5. So we now have 2 forces. Now we need to resolve those into, or add those into 1 using Pythagorean theorem. Number 5, determine the relationship between the net force on the object in question 4 and the object's acceleration. The relationship between net force and acceleration is Newton's second law, and I want you to figure out what Newton's second law is. So I want you to think of that. This is Newton's second law here. I want you to figure out what that is. Number 6, what would be the acceleration of an object in question 4 if it had a mass of 3 kilograms or 6 kilograms? So we'd first find out the force on from question 4, right? And then we use Newton's second law to figure out what the acceleration would be given the force and the 2 masses that it's given here. So we have masses of 3. So we're going to have 2 answers to number 6. So you use number 4 to find out the net force. And then once you find that out, you're going to use the mass to solve for the acceleration given Newton's second law. This right here says determine the relationship between force, mass, and acceleration. So we're just trying to figure out, okay, when force is this and mass is this, acceleration is this. So when force is this, mass is this, acceleration is this. When force is this, mass is this, acceleration is this. What is the relationship? When we have a force of 10 and a mass of 2.5, our acceleration is 4. When we have a force of 5 and mass of 10, our acceleration is 0.5. What are we doing with force and mass to get acceleration? Once again, think of Newton's second law. Number 8. Describe all the force acting on an airplane as it is flying. How does that affect its motion? So think of an airplane. It's kind of like the car question. It's going to be flying at a constant rate. You need to figure out all the forces that are acting on it, and what does that do to its motion? How does force affect motion? Number 9, identify 3 pairs of forces acting between 2 objects. It already gives you some examples, and so just come up with some examples in everyday life where you have a force acting and reacting. Like you punch the wall, it punches your hand back. Things like that, where you have one force acting, it causes an equal and opposite force, because every forces always come in pairs. Remember that, forces always come in pairs. And for the last page here, if I hit a wall with 15 newtons of force northward, what is the direction of magnitude of force the wall exerts on my hand? Well, it's going to be equal and opposite. So think of it that way. What's equal and opposite of 15 newtons northward? Number 11. Provide 2 examples of practical applications of Newton's third law. What happens with Newton's third law, and when can we use Newton's third law in everyday life? Now, number 12 is a little tricky. It says, relate the historical development of Newton's law of motion to our current understanding of the nature of science. Think of the poster I have on my front of my classroom that says something along the lines of, I can see farther than others by standing on the shoulders of giants. That's what one of Newton's famous quotes. Basically, he used the information from previous scientists to build up what he knew. And that's kind of how we use Newton's laws of motion. In the historical development of Newton's laws of motion, we use our previous knowledge to build upon and to improve our future, or improve our and understand the nature of science now. So that question was one from the core. Doesn't really make a ton of sense, but they wanted you to understand it. So that's why I have that one on there. I'm not too worried about it. If you have any other questions, feel free to call me or text or email, or we can do a Zoom meeting if we need.